Hi folks, well today before we get on with any maths we're going to have to think about books a bit because it's World Book Day. So the book I'd like to bring to your attention today is Catch-22 by Joseph Heller, which is a great book. They made a really good TV series of it about a year or two ago, which I well recommend, which was an amazing feat because it was one of those books which I really think is pretty much impossible to do, but they just about managed it. But the book is all about an American in the Second World War who's has to fly missions in a bomber from the south of Italy, and he's having to do this every day, and he's absolutely scared of dying. He's always looking for a way out, and then he hears that it's possible one of the people who's flying missions with has definitely gone mad, and he discovers that actually if you're insane you don't have to fly, even though they keep telling you you've got to fly, but there is a catch, and that catch is Catch-22. So I'm just going to read you a little bit of that now. There was only one catch, and that catch was Catch-22, which specified that a concern for one's safety in the face of dangers that were real and immediate was the process of a rational mind, or was crazy and could be grounded. All he had to do was ask. But as soon as he did, he would no longer be crazy and would have to fly more missions, or would be crazy to fly more missions and sane if he didn't. But if he was sane, then he had to fly them. If he flew them, he was crazy and didn't have to, but if he didn't want to, he was sane and had to. Yossarian was moved very deeply by the absolute simplicity of this clause of Catch-22 and let out a respectful whistle. "That's some catch, that Catch-22, he observed. "It's the best there is," Dr. Decker agreed. And that's it. Now, the whole book is about, as it goes on, he starts to feel that Catch-22 is being used for everything. In fact, he starts to think Catch-22 doesn't exist other than as an excuse for people to tell him that he can't have what he wants. And that's often what life feels a little bit like. But anyway, we've got some maths to get on with. Right, we're going to finish off with a nice easy topic, I think, of plans and elevations. Mind you, I did go to university to study architecture, and we had to do all of our drawings as plans and elevations, nearly all. We did do a few 3D ones, but basically plans and elevations are 2D drawings of 3D objects designed so that you can measure them in order to then build those 3D objects. And the reason it works is because so many buildings that we make these days and always have got vertical walls and horizontal floors, and so therefore it makes sense to do them in 2 dimensions because it's much easier to read what you're trying to do. Now, if you don't find this easy, many people don't find it easy, and it's just one of those interesting things about how differently we see the world. I always been really bad at sort of keeping in time, and when I was in the orchestra at school, I don't know why I was in the orchestra at school. I would have been much happier not to be there, to be honest, but anyway, that's another story. But yeah, I was always coming in about half a beat too late, and I thought I was doing fine, but hey, there you go. Right, so this is much the same. So the plan is what you could think of as the bird's eye view. Looking from above, you can see these 2 lines here. Well, they've happened because front elevation, what we're looking at, this object is a trapezoid prism. So the constant cross section is a trapezium. From the side, it's just going to look like a flat wall. From above, you get these lines because you've got the shorter side at the top of it. So all they're looking for you to sketch, there's a couple of ways of doing this, is you could just sketch your front elevation looking just like what is there. And then because the whole thing is just going back at a front, you could then just put in a line doing that. And then if you draw lines coming off here and here to be parallel with those and about the same length, then you get the thing popping along there. Now if you wanted to, you could say that it was a see-through solid, and if you really wanted to, you could dot in what's going on there, but that you don't have to. Now the other way of doing it, and those of you who've done lots of sketching maybe in DT and on isometric grid paper, is you could look at that corner there and say, right, if I have that as the front corner, I could have the base, I could be able to see two sides of it, and then I would be going up at an angle, and that could go across to there, and that would give me something like that, with that being the front. Whereas in this one, that was the front, that's the side, that's the side. Now it does say give the dimensions of the solid on your sketch, because it said at the top it was on a centimetre grid. So to give the dimensions, what you do is you put a little arrow from one bit along to there and write 1, 2, 3, 4 centimetres. At the top here I could say, right, that is 2 centimetres, and then coming along here up the side, that is 1, 2, 3, 3 centimetres, and that's the dimensions popped on. You don't need to worry about sort of any more than that. You don't need the diagonal bit in there, because that would need a bit of Pythagoras to work out, wouldn't it? And if you were doing it on here, that would be your 4 centimetres from there to there, your 3 centimetres from there to there, and your 2 centimetres, you could pop it in from there to there, or you could put it up there. It's up to you. So here's question 2. Pause the video and give it a go. It's in just the same way as the one before was. So I'm going to do it both ways again, because I like showing off. So the front elevation would be just something like that, and we could put the dimensions on at the same time, so don't forget that. That's 3 centimetres. That's 1. That's 1, and then you could go back that way, or you could go that way. I think I'm going to go this way, so it'll then go and you see I overrun there a bit, but it doesn't really matter. It is 3 centimetres by 3 centimetres, isn't it? So that'll be 3 centimetres there, and I could pop in a 2 centimetre bit there, couldn't I? Now if you like doing it so that it's sort of coming towards you a bit more, you could have got your longer side coming towards. You could do it so the long bit was at the back if you wanted to. It doesn't matter. Something like that. Get rid of that bit. Going along the side, back 3 centimetres. There would be something like that, and then this bit's a little bit trickier. It's going to be about like that. So there we've got 3 centimetres going to there. We've got 3 to there. We've got 2 up the side. 1 centimetre there would definitely be enough. It's only 2 marks, so don't get too worried about putting too much in. Okay, question 3. Let's have a crack at that. Pause the video and have a go. So I'm looking straight down on it. This is a cylinder, isn't it? Looking straight down on it, and it's a circle from either side, front or side. It's just a rectangle, so it must be a cylinder. So we can start off a cylinder by drawing an ellipse in 3D and then pop it down there. If you did a circle on the top and half a circle at the bottom, there would be no problem. Quite nice to put in a dotted bit for what's behind. And then in terms of dimensions, you just need the height, which is 3 centimeters, and either the diameter or the radius. So 4 centimeters if you're going for diameter. If you'd rather go for radius, that would be 2, but you definitely don't need both of those on there. Right, here's question 4. So on the center, so this time we're being given what it looks like in reality in 3D, although there's no perspective on these. This is an isometric drawing, and then we need to do the plan and a side elevation. So the side is going in from there. Now if you imagine being there, it's going up at the right, isn't it? So our side elevation is doing that. So just write in side elevation. Doesn't matter which way round you did it. If you've already done it and you put it over there and you put the plan over here, that's fine. Now if you imagine being a little birdie flying over the top, we've got a stack up there at the top that we can see, and then it comes across 2 and down 1 like that, with that being the side, and that is the plan. Question 5, pause the video, have a good look at it and think about what you're going to have here. So it's a cone. Looked at directly from above, you're going to have a circle, aren't you? So in order to do this, you really need to get yourselves a compass, which you would have in the exam. If you haven't got it, pause the video, go and find one now. That's what I'm doing. Now, if like me, you've printed this off at 2 pages to 1, then it won't be a full centimetre, and our radius is only going to be smaller than it should be. The radius is 3 centimetres, so the radius would be, if that's the centre, the radius is going to be that far there, which is a bit tricky to do on a compass, and mine's very wiggly. So if it is wiggly, you'll want to find yourself a what's it called, screwdriver, and tighten it up a bit. That's what I'm going to do now. Right, so put this right. Now when you're using a compass, just in case you're not too comfortable with one, you want to put all your weight on the center. I'm only just letting the pencil touch the paper, and then I'm just going around again. And it's worth spending, if you're not much good at, we don't spend much time practicing with compasses, so if you're not confident, get a screwdriver, get it nice and tight, and then practice your compass skills, because the more you do it, it suddenly gets very, very easy after a while. So anyway, here's the plan, and the side elevation is going to be 8 centimeters high, and 6 wide all in all, isn't it? So if I make sure I've gone across to there, right from there, that's the top of my cone. 1, 2, 3, 4, 5, 6, 7, 8. And it's very important that you do count right, because these are really easy marks, but they're easy to throw away as well. So that's 3 centimeters to the side, there's another 3 centimeters to the other side, and then join them up. Now you should be using a pencil for this, really. I'm just using a pen so it shows up a little bit clearer. And the important thing though is in side elevation on the cone, the bottom would not appear to be curved, because it would be totally horizontal. So, and it doesn't matter which side it is, but anyway, here's side elevation, and make sure you just label it so that whoever it is who's marking can't have an excuse for thinking that you don't know what you're doing. Here's question 6. Pause the video and have a go at this. Hopefully you're getting quite good at it now. It's up to you whether you do the front or the side elevation first. So they haven't asked us for the plan, so we're just looking on from the front, and from the front it's 3.5 meters high altogether. So this is going to be a little bit technical because they're saying 2 centimeters to 1 meter, 2 centimeters to 1. So 3.5 meters is going to be 2 times 3.57 centimeters, which means 7 squares, doesn't it? So I'm going to start there at the top. In fact, let's go over a little bit further towards the side. We've got two, 4, right. So if I start here and I go down 1, 2, 3, 4, 5, 6, 7, then it's going to need to be 4 meters is going to be 8 squares. So that'll look like that. And 2 meters will be 4 squares. And that means that it looks a little bit, it doesn't look exactly the way they've drawn it, because they've drawn 2 meters as that height, therefore saying that's 1.5. So it's not, sorry, that bit there is nowhere near big enough to be 1.5 compared to the 2 there. So they have drawn it slightly out of proportion. So what I'm doing here is right, as opposed to their sketch isn't so. But of course it's a sketch, so it doesn't have to be. All you have to do, because they've put the dimensions on, that means you can work out what it should be. So this is the front elevation. And then for the side elevation, it's going up to the same height. It's 3 meters, which is 3 times 2 is 6 centimeters, or 6 squares. 1, 2, 3, 4, 5, 6. It's going up to the same height, as we can see from here. And when architects draw their plans and elevations, they do line them up so that you can see what's going on, or at least they used to before computers started to come in and take all the fun away. And that's one thing that drove me away from architecture, to be honest. I liked sitting at my drawing board and doing drawing with my hands, but actually everyone wanted computerized drawings because you can change them quickly without having to scratch things out on tracing paper as we had to do before, which just takes a bit of fun out as far as I'm concerned. And the other thing is it takes just as long to draw something on the computer as it does by hand. Anyway, stop moaning now. Side elevation. If I hadn't stopped being an architect, I never would have met all you lovely people, would I? Okay, so there we go. That's question 6 done. We've just got one question left to do, which is question 7, which is there. Square base pyramid with a perpendicular height of 400 centimeters, using a scale of 2 centimeters to represent every meter. Pause the video, give that a go. Right, so what we've got to do now is draw the plan and front elevation. Now it says it's 300 centimeters wide. How long is it there? Well, it's a really good idea, because I started drawing this down here. I thought I was going to have to start using a bit of 3D Pythagoras to work it out, but I don't need to, because it said it's square based. So if it's square based, that means that that is also 300 centimeters. So if it's a square base, the plan must be a square that's going to be 3 centimeters, well, not 3 centimeters, 300, so that's 3 meters. So 3 meters is going to equal 6 centimeters on the scale. So if I go from the side here to give myself plenty of room, 1, 2, 3, 4, 5, 6, and then down 6, 2, 4, 6, 6, and 6 there. So all we have to do here is put a dot in there, but not just that. We also need to acknowledge the slopes, because they're going to appear as lines. If you were a bird flying above and looking down on it, you would be able to see those lines. Now there'll probably be some shading as well, but you don't need to worry about that. If in an architect's drawing we would have put some shading in from one side, heavier there and then maybe a bit lighter there or something. You've probably done much the same in DT at some point, some of you. Anyway, that's the plan. The front elevation will also be 6 squares wide, but it's going to be 8 squares high to reflect the fact that that is that's how high it is, isn't it? 4 meters being 8 of those. So if I go down 1, 2, 3, 4, 5, 6, 7, 8, and then it's going to be the same width that we had on the plan, so that's 3 centimeters either side, and put that in there and that in there. And remember, in the exam use a pencil, and there because if you make a mistake it's so much easier, and it is very easy to make a mistake. And then we can just write front elevation, because that's what they asked you to call it, although if they'd said side elevation it would have looked just the same. Right, and that's it, and see you all on Monday. Bye bye.